Welcome back, everyone. Ready to dive into some really cool science.
Always.
Today, we're tackling a topic that's straight out of science fiction. At least, it seems that way.
Oh, yeah.
We're talking sonic crystals and acoustic metamaterials. Bending sound, cloaking things from sound, that kind of stuff. And our listener wants to know 5 specific things, actually.
Hit me with them.
Okay, so first, what are sonic crystals? How do they work? Then, what are acoustic metamaterials? Those sound even more futuristic. Then, of course, we got to talk about sound cloaking. Is that even real or just a movie thing?
Ah, the invisibility cloak of sound.
Right. And then, this is more down to earth, but how are sonic crystals in these metamaterials changing noise cancellation? That tech is everywhere these days.
Yeah, it's pretty common, but there's always room for improvement, right?
Exactly. And last but not least, the listener wants to know how sonic crystals are being used in medical imaging, which sounds kind of crazy to me.
Oh, it's fascinating stuff, actually.
Okay, so maybe let's start with sonic crystals. What exactly are they?
How to explain it? Imagine like a maze, but for sound.
Okay.
So it's a material, but it has this specific repeating pattern built into it. Like, think of tiles on a floor, but these tiles can block certain sound frequencies while letting others pass through.
Wow, so it's not just absorbing sound like, I don't know, a thick curtain or something.
No, it's way more selective than that. It's like it can actually sort the sound.
That's wild. I'm imagining, like, living near a freeway but only hearing the birds chirping. Is that even possible?
That's the idea. With sonic crystals built into walls and stuff, you could potentially block out all the traffic noise but still hear the nice sounds.
That would be a game changer for city living, for sure. Okay, so that's sonic crystals. Now, what about these acoustic metamaterials? How are they different?
So these are even more high-tech. We're talking materials that are engineered at a microscopic level.
Microscopic, wow.
Yeah, they have these tiny structures that allow them to do way more than just block sound. They can actually bend the sound waves, focus them, redirect them, things you just can't do with natural materials.
So is that how they're getting closer to, like, sound cloaking, like those invisibility cloaks in movies?
You got it. Making something totally invisible to sound is still really tricky, but these metamaterials are a big step in that direction.
I can't even imagine, like, a submarine that's completely silent to sonar.
Yeah, that's one application they're exploring. Or imagine like quiet zones around schools or hospitals where even though there's noise all around inside, it's peaceful.
That's amazing. Okay, so let's shift gears again to something a little more familiar, noise-canceling headphones. Everyone's got them these days. How are sonic crystals and acoustic metamaterials changing that tech?
Well, most noise canceling headphones now, they just kind of create an opposite sound wave to cancel out the noise, right? But with these new materials,
It's more precise.
way more precise. They can target very specific frequencies or even types of sounds. So instead of blocking everything, you could block out, I don't know, the annoying hum of an airplane engine, but still hear people talking to you.
Oh, wow, that's so much better.
Or imagine being in a cafe, but instead of hearing everyone's conversations, your headphones just filter it so you only hear the person you're with.
That's incredible. It's like creating your own little sound bubble.
Exactly. Personalized soundscapes, that's one of the big promises of this tech.
Okay, last one, medical imaging. I'm honestly struggling to wrap my head around how sound can help us see inside the body.
Yeah, it's not intuitive, but think about ultrasound, right? That already uses sound waves to create images of our organs.
Right, right.
So now imagine adding sonic crystals into those ultrasound devices. They basically act like tiny little mirrors for sound, carefully positioned to redirect the waves.
Oh, so you get a clearer picture.
Not just clear, much more detailed. And with more detail, doctors can potentially spot things earlier, make better diagnoses.
Wow, so it's like giving them a way more powerful tool to look inside the body.
Exactly, and that could totally change how we detect and treat diseases in the future.
This is mind-blowing. I feel like we've only scratched the surface here. There's so much more to uncover about how these materials are changing. Well, everything about sound. But before we get too carried away,
Welcome back. It's fascinating to consider how manipulating sound can revolutionize medical imaging.
it really is. It's amazing to think we could use sound to see inside the body with that kind of precision. You mentioned sonic crystals could enhance ultrasound technology, but what kind of impact could that have on healthcare?
Well, think about it. We already use sound waves to like break up kidney stones, right? And target tumors.
Right.
So with sonic crystals, we could make those techniques even more effective, less invasive too.
So it's not just getting a clearer picture, it's actually about improving how we treat diseases.
Precisely. I mean, imagine a world where sound is our primary tool for healing. That's the potential we're talking about.
Wow, that's a powerful thought. Sound is a healing force. But okay, let's go beyond just treatment for a second. Could sonic crystals help us, like, understand the human body in new ways?
Absolutely. I mean, imagine using sonic crystals to map brain activity in real time, or to monitor like really subtle changes in blood flow that could be early signs of a disease.
So we could potentially diagnose diseases much earlier than we do now.
Exactly. Early detection is key for so many conditions, and with sonic crystals, we could be moving towards a future where we catch diseases before they even become a problem, you know?
That's incredible. Okay, so we've talked about architecture, noise cancellation, medical imaging. But I don't know, I can't help but wonder if this technology has implications even beyond those fields.
Oh, absolutely. The applications of sonic crystals and acoustic metamaterials they're incredibly diverse. I mean, think about energy harvesting, for example.
Energy harvesting?
Yeah, we could potentially use these materials to capture sound energy and convert it into electricity.
So, like, we could power our devices using sound.
It's not outside the realm of possibility. Or imagine using sonic crystals to create like hypersonic communication systems.
Hypersonic communicate. That sounds like something straight out of Star Trek.
It does, doesn't it? But that's just scratching the surface. These materials could be used in everything from advanced sensors and actuators to creating new types of musical instruments and sound art installations. We're really just at the beginning of exploring all the possibilities.
It's exciting to think about how all of this could impact our lives in so many ways. But okay, let's be realistic for a moment. What are some of the challenges that researchers are facing, to actually bring all these applications to reality?
Well, one of the biggest challenges is scalability. Right now, producing these materials it's relatively expensive and time consuming, especially on a large scale. So we need to find more efficient, more cost-effective manufacturing methods to make these technologies accessible, for widespread use.
So it's like the early days of computers. Incredible potential, but not quite ready for the mass market yet.
That's a good analogy. And another challenge is complexity. These materials require very, very precise designs and manufacturing techniques to actually achieve those desired effects. So we need to develop more sophisticated modeling and simulation tools to make the design process, more efficient, more reliable.
So it's not just the materials themselves, it's the tools and techniques we use to work with them.
Exactly. And then there's the challenge of integration. How do we seamlessly incorporate these materials into existing systems and structures? How do we ensure they're durable and reliable in real-world environments?
It's like building a bridge between the lab and the real world.
Precisely. But these challenges, they're not insurmountable. Researchers all over the world are making incredible progress in all of these areas. And as the technology matures, the cost will come down and the applications will become even more diverse, more widespread.
It really seems like we're on the cusp of a sonic revolution. This has been an incredible journey into the world of sound manipulation, but unfortunately we're going to have to wrap things up for today.
It's been a pleasure diving into this fascinating topic with you.
Thanks for joining us on this deep dive into the amazing world of sonic crystals and acoustic metamaterials. Until next time. Welcome back to our deep dive into sonic crystals and acoustic metamaterials. We've covered some pretty mind-blowing stuff, from sound cloaking to hypersonic communication, and it really feels like we're on the edge of a sonic revolution.
It is remarkable how much our ability to manipulate sound has advanced. We've gone from just trying to dampen noise to actually shaping it, controlling it. It's like we're becoming composers of our own acoustic environment.
That's a great way to put it. But with all this power, comes responsibility too, right? We have to think about the potential downsides.
You're absolutely right. Like with any powerful technology, there's always the risk of unintended consequences. For instance, if sound cloaking becomes really widespread, what does that mean for our privacy in public spaces?
Yeah, that's a good point. Could someone use it to like eavesdrop on conversations or even commit crimes without anyone knowing?
Exactly. Those are things we need to think about carefully. And it's not just privacy. Imagine the potential for, weaponizing sound. Could you use these materials to make some kind of sonic weapon that causes pain or disorientation?
That's a pretty unsettling thought, but yeah, we definitely need to address these concerns before this tech gets out into the world.
Absolutely. We need to start thinking about ethical guidelines, regulations, all of that now to ensure that it's developed responsibly. It can't just be about scientific progress. It has to be about making sure this progress benefits humanity as a whole.
So it's like a balancing act, right? Pushing the boundary of what's possible, but also thinking about the risks.
Exactly. It's about harnessing the power of these materials while safe manning against their misuse.
It's fascinating to think about the future, right? I mean, on one hand, we could have these personalized soundscapes that make us feel better, more creative. But on the other hand, there's the potential for I don't know, too much control, maybe even damage to our sonic environment.
Finding that balance is going to be key. We need to be aware of how these sonic technologies can shape our lives, our world, and make sure we're using them in ways that are both beneficial and ethical.
It's a good reminder that technology should enhance our lives, not control them, right? We need to find ways to integrate these innovations while still respecting, our humanity and the natural world.
I think that's a great takeaway. Sonic crystals and acoustic metamaterials have incredible potential, but it's really up to us to shape a sonic future that is both innovative and responsible.
Well said. This has been a truly incredible journey into the world of sound manipulation. Thanks so much for sharing your expertise with us today.
It's been my pleasure.
And to our listener, thank you for joining us on this deep dive. We hope you've learned something new and exciting about the world of sound and the potential of these amazing materials. Until next time, keep exploring, keep questioning, and keep listening. 65 Simo.